9.6, solving rational equations. Remember, rational equations are equations that include rational expressions. Rational expressions are your polynomial expressions in fraction form. So let's look at our first method for solving these rational equations. One method to solve rational equations is the LCD method, where you would find your lowest common denominator and you would multiply each term on both sides by that lowest common denominator. Remember, the purpose in multiplying by the lowest common denominator is to eliminate all denominators. The purpose in multiplying by that lowest common denominator is to eliminate all denominators so that you have a new equation with no rational expressions, no denominators. After multiplying by that LCD, you'll want to simplify and then solve the resulting equation. So let's look at one example. Here we have a rational equation. The first step, find the LCD. Sometimes to find that LCD, we need to factor the original denominator. So you want to look at both of your denominators. Your first denominator is x minus 4. This denominator will not factor, but your second denominator, x squared minus 16, you should recognize this as the difference of two squares, which will factor into x minus 4 times x plus 4. Just draw a single line through the original denominator to show that you're no longer using that denominator, you're now using the denominator in factored form. Then, using the LCD method, we want to multiply every term in the original equation. Take every term and multiply it times the common denominator of x minus 4 times x plus 4. Well, remember, we're multiplying this common denominator times every term. So this gets a little tedious to write it 3 different times, so we're going to just write it this one time, but remember, we have to multiply this common denominator times every term. So we're going to take it and multiply it times the first term. When you multiply it times the first term, you can cancel out the x minus 4 in this denominator with the x minus 4 that we are multiplying by in our common denominator, and end up with just the numerator 2x plus 1 times the x plus 4 of the common denominator we're using. Then go to your next term, multiply by the common denominator, and you'll end up canceling out the entire denominator so that leaves nothing to multiply this term by, and so we just end up with our numerator 16. Plus, now I take the last term, 3. Now remember, the understood denominator here is 1, so there's nothing to cancel with our x minus 4 times x plus 4 that we're multiplying by here. So just multiply the 3 times all of the x minus 4 times x plus 4. We can take a little bit of a shortcut and go ahead and multiply the x minus 4 times x plus 4 together. Because this is our sum and difference pattern, we know that when we multiply x minus 4 times x plus 4, that it will equal x squared minus 16. Come back, use FOIL, do 2x times your x, end up with 2x squared. 2x times the 4 gives you a positive 8x. 1 times the x would give you a positive 1x, and 1 times the 4 would give you a positive 4. On the right-hand side, bring down your 16, distribute your 3, gives you 3x squared minus 48. Come back, put your like terms together. 2x squared plus 9x plus 4 would be equal to 3x squared minus 32. It's always simpler to move all of your terms in a direction that would keep A positive. So let's move everything over to the right-hand side, leaving the left-hand side equaling 0. So subtract 2x squared from both sides. Subtract 9x from both sides. And subtract 4 from both sides. So a negative 32 minus 4 would give you negative 36. Now you want to factor your resulting trinomial. This trinomial is going to be a little easier to factor than some because the A term is an understood 1, so we can go straight to x times x. Remember to look at the sign of your last term. That sign of that last term will determine for you if you have two signs that are the same or two signs that are opposite of each other. Because this last term is negative, you know that you need a positive term and a negative term. Now we need numbers that we can multiply to get 36 and that we can take the difference of to get 9. Since our signs are opposite of each other, we know that we'll be taking the difference to get 9. So the factors that we need would be 3 times 12, where the 3 would be the positive term and the 12 would be the negative term. You can always check your factoring by multiplying it back together, at least mentally checking, making sure that your factoring will result back into what it was before you factored. Okay, use your zero product property to find your solutions. So x plus 3, from this term you know that x would be equal to a negative 3. And your x minus 12 term, you find that x would be a positive 12. So we have two solutions. Remember to always come back and check those in your original equation. Let's do a little bit of erasing here so you can see what the original equation was. You always want to check and make sure that you end up with nothing here would give you a 0 in your denominator. It's always a good idea to at least check that, because any solutions that would cause you to have a 0 in the denominator, you have to eliminate those solutions. And you could plug it back in and just make sure that you've made no careless mistakes. After checking, let's move on to the next problem. Alright, so LCD was one method, but remember, for the simpler rational equations, there is another method. We can cross multiply. But remember, this cross multiplying method can only be used when you have a single rational equation or single rational expression on each side of your equation. Okay? So only use the cross multiplying method when there's a single rational expression on each side. So let's look at the cross multiplying method. With this problem, because we only have a single rational expression on each side, we can use the cross multiplying method. We can multiply negative 2 times the x plus 1, and that would be equal to multiplying the x minus 1 times the x minus 8. And what we've done is we've multiplied our extremes, multiplied our means, and ended up with a new equation where all denominators have been eliminated. Okay, so now distribute. Negative 2x minus 2 will be equal to x squared minus 8x minus 1x plus 8. Combine your like terms. Negative 2x minus 2 then would be equal to x squared minus 9x plus 8. Subtract 2x from both sides. Add 2x to both sides, so x squared minus 7x, and then add 2 to both sides. You would end up with a positive 10. So 0 would be equal to x squared minus 7x plus 10. Factor your resulting trinomial. Again, because A is an understood 1, this is a simpler one. We can just go straight to factoring it. You need factors that will give you 10. Because 10 is positive, you know the signs are the same, but the middle term is negative, so these terms have to both be negative. You're going to multiply and get 10, add and get 7. The factors that will do that are 2 and 5. Use your zero product property to find that x is equal to 2 and 5. Remember to check those back into your original expression and make sure that neither one of those will give you 0 in the denominator. Alright, so when we're solving rational expressions, there are two methods. Method 1, use the LCD. Use the LCD method. With the LCD method, you would multiply all terms by your lowest common denominator so that all denominators are eliminated, simplify, and solve the resulting equation. Okay. Method 2, with method 2, you would use this only with simple rational expressions where you have rational equations where you have just a single rational expression on each side, and with this method you would cross multiply. You would multiply your extremes, and that would be equal to when you multiply your means. So two different methods to use when solving rational equations. Let's look at one word problem. This is a very common word problem that you will see on SATs and all types of standardized tests. Very common word problem. In this word problem, let's read it first. It says it takes a speedboat 30 minutes to travel 6 miles up a river and 6 miles back, going at a steady speed of 25 miles per hour with respect to the water. Remember, with respect to the water, we have to think about upstream and downstream. Upstream, we would be pushing against the current, and downstream, the current would be pushing us along. So while the boat itself may be traveling 25 miles per hour, the current of the stream would affect our speed. And so they want us to find the speed of the current. Well, this is a distance problem, so we first need to start with the idea that distance is equal to rate times time. Distance is equal to rate times time. Time is the only thing that we know about this problem. We know the entire time, so let's rewrite the distance formula in terms of time. If I wanted to get time by itself, I could divide both sides by the rate. That would eliminate the rate with the time, and so we would have time is equal to the distance divided by the rate. Well, in our equation we have two different distances. We have the distance upstream and the distance back downstream, and we have two different rates. Although our boat is traveling at 25 miles per hour, it's affected by the current. So we have our distance upstream and our rate that we're going upstream. Since we're going upstream, it would be minus the current, because the current is working against us. Plus, we have our distance that we're traveling downstream at a rate of 25 miles per hour, plus the current. If we're going downstream, the current would be pushing us downstream. So we want to find that current. Alright, now the time that they've given us is in minutes, but the rate that they have given us is in miles per hour. So this time needs to be written in hours. Remember that 1 hour is equal to 60 minutes, so we can say that it's 30 minutes divided by 60 minutes. Okay, so our time can be reduced to 30 minutes over 60 minutes, or to 1/2 hour. Alright, so our time would be 1/2. Our distance, we traveled 6 miles up the river and 6 miles back down the river, so our distance both directions is 6. Our original rate was 25 miles per hour, but then that's affected by the current, so that's 25 miles per hour minus the current when we're going upstream, plus the distance downstream, divided by the rate going downstream, which would be 25 miles per hour that the boat is traveling, plus the current that's pushing us. All right, so we have a rational equation. Now, because this is a more complex rational equation, to simplify this rational equation, we would need to multiply by the lowest common denominator. We have two denominators, 25 minus c, 25 plus c, and we also have the 1/2, the denominator of 2. So our lowest common denominator here, let's think about that. Your lowest common denominator here would be 2 times the 25 minus c times the 25 plus c. And we're going to take and multiply every term times this common denominator of 2 times the 25 minus c times the 25 plus c. We're going to take that common denominator, remember, and multiply it times every term in your equations. You can take and multiply it times the 1/2. When you do, the 2's will cancel out, and you'll just be left with the 25 minus c times the 25 plus c equals. Now go to your next term. In your next term, the 25 minus c will cancel out, and you will be left with 2 times the 6, or we could go ahead and say 12, times, since we canceled out the 25 minus c, we would just be left with the 25 plus c. Plus, let's take our last term. Our last term, we would cancel out the 25 plus c's. We would be left with 6 times the 2, or 12 times the 25 minus c. Remember, in the last term, we canceled out this 25 plus c. All right, come back and simplify. Well, 25 minus c times 25 plus c, this is your sum and difference pattern. So what we need is the 25 times 25, or 625, minus, remember, it's your sum and difference pattern is a squared minus b squared pattern, so you just need your b squared, or actually c in this case. On the right-hand side, let's distribute 12 times the 25, end up with 300, and 12 times the c, plus 12 times 25 again is another 300, and then 12 times the negative c would be a negative 12c. Okay, combine like terms, so we would end up with 625 minus c squared is equal to 600. Subtract 625 from both sides, we would have a negative c squared is equal to a negative 25. Divide by the negative 1, we would have c squared is equal to 25. Take the square root of both sides. C would be equal to a positive and a negative 5. Okay. Well, we're wanting to know the speed of the current. What speed is the current moving at? The current would be moving at a positive 5 miles per hour. Okay. If you think about, if you're moving upstream, you're moving downstream, the answer that we're looking for is 5 miles per hour, but when you're moving upstream, the current is going against you, so it's slowing you down maybe at 5 miles per hour, and you're moving downstream, it's pushing you ahead at an extra 5 miles per hour. So there we have it. Hope this was a good review for you. See you tomorrow.